Hello, my name is Dr. Ali Shahidinejad, and welcome to this brief overview of the software-defined networking unit. In this unit, students will explore how SDN changes traditional networking by separating the control plane from the data plane. Unlike traditional networks, where each device independently handles control and forwarding, SDN introduces a centralized controller that intelligently manages the flow of data across the network. This is particularly relevant in modern environments such as data centers, 5G infrastructures, and cloud-native systems, where scalability, agility, and automation are essential. To understand the value of SDN, we start by comparing it with traditional networking. In traditional architecture, the control logic is embedded, as you can see here. The control logic is embedded in each network device, making centralized management difficult and costly to scale. SDN, as you can see here on the right hand side, solves this by separating the control logic and placing it in a centralized controller like ONOS. And this controller communicates with network devices through standardized protocols such as OpenFlow. And as you can see, the architecture consists of three planes. We have data plane, which handles packet forwarding, and then we have control plane, which makes decision about where traffic should go. And finally, we have the application plane, where network services like routing, firewalls, and load balancing are programmed. This layered approach gives admins greater flexibility and makes networks more programmable. One of the key strengths of this unit is its focus on hands-on learning. We use Mininet, a lightweight emulator that lets students create and test network topologies in seconds without the need for physical devices. To control these topologies, we introduce ONOS controller, a production-grade open-source SDN controller. The students use ONOS to deploy policies, route traffic, and interact with switches using APIs. We also explore scripting with Python using REST APIs for automation and Wireshark for traffic analysis. This practical exposure equips students with real-world skills and confidence in programmable networking. My teaching philosophy is grounded in active learning. Each week features a short lecture, followed by interactive lab sessions where students work directly with Mininet and ONOS. To deepen learning, we apply a flipped classroom approach for complex topics. The students review material before class, and we use our time to solve challenges together. Assessments are designed to be both rigorous and engaging. We have lab reports, which assesses technical skills and analytical thinking. We have a group project, which asks students to design and evaluate their own SDN architecture. This fosters collaboration and problem solving. And then we have quizzes, which ensures foundational knowledge is retained. And we have participation and reflection. These are activities that encourage students to think critically about what they have learned and how to apply it. To wrap up, SDN is a transformative concept that empowers students to move from traditional manual networking to programmable intelligent infrastructure. By the end of this unit, students will have developed foundational understanding, hands-on skills, and the confidence to contribute to real-world SDN environments. Tools like Mininet and ONOS help them simulate realistic network scenarios and apply policy-based control at scale. My goal is to create a collaborative and supportive learning experience where students not only learn concepts but also practice them in a way that reflects modern industry needs.